Welcome to another exciting round of Multiplying Mayhem. I'm your host, Mayhem Matt. Let's let the mayhem begin. Well, when we chatted last week, if memory serves, we were talking about factorials and how fun and frolicking factorials can be. But we also talked about how can we actually use them in a real life situation. Well, I'm going to keep my word and show you that right now with, let's see, which side of the board do I want to stand on? Let's start over here with combinations is how we're going to start this program. This right here, my friends, is the combination formula. This is read NCR. If you had values, say 5 and 3, it would be read 5C3, just FYI information. Our formula here is n factorial. You remember last week when we spoke about factorials, we said we had to enunciate, so this would be n factorial. Remember? Okay, I know you do. Well, that is going to be divided by this r factorial, and I'll tell you what all this means here in just a minute, okay? We've got the r factorial, and that's going to be multiplied by what's in the parentheses here, n minus r factorial. Whew, I know that seems like a lot, but it's not as bad as it seems. It's probably worse. But that notwithstanding, so what we have here is the C stands for combination, duh. But n is going to represent the entire set that we're going to be referencing, okay? This could be just any elements, objects that you can think of. That would be our total. Now the R, or sometimes you will see it represented as a K. Can't remember if I've already said that or not, but you can see that as a K sometimes as well. And that would be the number that we are choosing out of the entire set. So the entire set has 20, and we want to choose 5. That's what this represents. So let me just go ahead and go down the list here of what all these things actually mean. The NCR does represent the number of combinations. We're working with combinations. The N, as I already said, represents the whole set that we're talking about. The R represents the number of choices that we're working with. But last and not least is the constraints that we're working with in this particular formula. So we're choosing N, right? That's our full set of values, but we can't choose more than that. So our choices have to be equal to that or less than. And that's what's represented here with the R, being less than or equal to the N value. But it also has to be greater than or equal to 0. We can't make anything less than 0 as far as a choice goes, right? So it has to be equal or equivalent to 0. And if you are wondering, do I have a formula for you? An equation to work out? I don't know it's an equation necessarily, but it is a problem, and so let's deal with this problem. Now, before I go any further, if you have a smartphone, you might see the factorial represented like this on your smartphone if I have given you the inclination to start pursuing factorials more on a full-time basis. Or you might see it as an n factorial on a calculator. Maybe I think Casio has the n factorial. Not 100% sure. Don't quote me on that. All right, here we go. Well, remember we worked with 5 factorial last week, so we will work with it again this week. Why not? So here we go. This is 5 factorial divided by 2 factorial, and we've got 5 minus 2 in parentheses. That will be obviously 3 factorial. Now, let's just say, for example, we want to choose 2 people to represent, say we've got an ambassador program, for example, all right? And we want to choose 2 people out of 5. Well, how many different ways can we choose those 2 people out of 5? That's what this is saying. How many different ways can we pull 2 people out of this entire group? In the entire group are the number of people that we're choosing out of the entire group. All right, well, this is really kind of what we did last week with 5 factorial. We just multiplied 5 times 4 times 3 all the way down to 1, didn't we? We did. That gave us 120. Well, divide that by what's in the parentheses first. I mean, just basic algebra, right? 5 minus 3, or 5 minus 2 gives us 3, I should say. 3 factorial. Well, now we're left with 2 factorial and 3 in the denominator, right? Well, multiply those out together. 2 factorial, well, that would just be 2 factorial. 3 factorial, well, that would be 3 times 2, which would give us 6. So now we have 2 times 6, which is not that difficult, right? 12. 120 divided by 12 gives us 10. Woo! So this is saying that there is 10 possible ways, using this formula, that there's 10 possible ways to have 2 people represent our ambassador program out of a total of 5. Well, go clear your heads, have a beautiful day, and I'm wishing you a mayhem-free day as well.